my topology here. On my left-hand side and right-hand side, I have BGP 65001, 65002, 65003, and 65004. They are customer sites. In the middle, I have BGP AS100, where the service provider is running MPLS, BGP VPN-v4, and BGP AS100, and also with dual hub DMVPN, which is dual hub and also dual cloud. So what I have here is a design here, and I'm going to be demonstrating it in my videos. On switch 1 and switch 2, I'm having VTP running, version 2, domain name is Cisco, and the modes are servers. I also have spanning tree running, and switch 1 happens to be the spanning tree route for VLAN 10, and I have spanning tree mode MSTP running, and this bridge is actually the route for that. I also have port security running in case there's any violation. On switch 2, I've configured port security, show port security, so that if there's a violation, it will be shut down. I have these two links between switch 1 and switch 2 configured as strong and as ether channel. So say show ether channel summary, which are the two ports, and it's up, and show interfaces strong. I also have RIP running in between router 11 and router 13. Show IP route RIP. So receiving RIP route, I can reach R1, which is located far away in another site here, through RIP, because RIP is running between 11 and 13. I have a Multi-AF EIGRP on my DMVPN tunnel, and which is on router 7. I have show IP protocol summary. EIGRP is running on router 7, which is Multi-AF mode, show IP protocols, EIGRP, and also begin EIGRP. So here on my EIGRP, I have the 64-bit version, a metric weight K1 to K6, showing the 64-bit version. So if I say show run, break section EIGRP, I'm going to see the configuration in full here. So I also have OSPF and IPv4 redistribution on my router 9, which is a service provider network. I have OSPF running, show IP, OSPF neighbor. OSPF is running between all the devices in the service provider network. Show IP protocol summary, I have OSPF running here. And I have a mutual IPv4 redistribution running. According to my topology, I have configured redistribution on each point on router 11, router 12, and router 13, so that I have redistribution from OSPF to EIGRP here. On 11, I have OSPF to RIP, and on 13, I have RIP to EIGRP, yet avoiding loops. So I'm going to show that now. On router 12, show IP route, EIGRP, so I'm receiving external EIGRP routes due to redistribution. And I have redistributed OSPF into EIGRP, redistributed BGP into my EIGRP, and also vice versa. So likewise on my router 13, I have both RIP running and also EIGRP, where I'm also redistributing RIP into EIGRP and EIGRP into RIP. So the same thing on router 11 also. I have RIP and OSPF running. And I'm redistributing both of them, redistributing RIP into OSPF and also OSPF into RIP. So that's why I'm going to have external OSPF routes to avoid loops. I'm using type 1 in my redistribution all throughout. So I also have MPLS VPN running here. This is my service provider network. 7, 9, 8, 10, and 6 are my Ps. So show MPLS, LDP neighbor. So being my Ps, these are MPLS running. Then I can also say show MPLS forwarding table to see the labels for each of the ops. Then I have BGP VPN v4 running. Show IP BGP or summary. First, let's see the BGP neighbors. So I have configured BGP to the neighbor here, which is the customer site, 10.1.36.3. But within the service provider network, I've configured high BGP here running to each of the loopbacks. And I'm going to demonstrate it here. Show IP BGP or so showing each of the VRFs and the traffics connected or the routes, distinguishing on the routes for each of the VRFs. So additionally, I have configured a dual hop DMVPN. So these are my DMVPN spokes on router 7 and router 8. For my MPLS PE to C, BGP is running. For my dual hop DMVPN, I have on my router 7 2 hubs and router 8 has 2 hubs, show DMVPN. So my DMVPN is actually phase 3, show DMVPN, and I'm running phase 3 so that I can have a direct connection to the spokes. Trace route 192.168.2.8 numeric. Well, that's the first packet. Then I can go directly to the spoke. So, and I'm also running show crypto ISOCamp SA so that I have all my crypto ISOCamp SA running perfectly. That's the IPsec. Show crypto IPsec SA. So here I also have packets being decrypted and encrypted. Packets being decrypted and encrypted for my crypto ISOCamp SA. Encryption is going on. So I have DMVPN running. Okay, the 2 hubs, which are router 6 and router 10, then the spokes. So I've implemented my tunneling through the DMVPN. I've implemented my IP PIM sparse mode through the DMVPN tunnel. So first of all, demonstrate that. Show IP PIM interfaces. I have PIM running on my tunnel, on my loopback, and on the interface connecting to the servers here. So which is sparse mode. Show IP PIM neighbor. My neighbors are tunnel interfaces and also the interfaces connected to the server. And I've also configured my R6 and R10 as the candidate RPs. Show IP PIM RP mapping. So router 6 and router 10. And I can send traffic down through this tunnel link. So if I say I'm pinging the group, just gonna repeat too, so that I'm able to reach here. So router 6 and router 10, this is bootstrap running in my topology. And router 6 is definitely preferred over router 10 because of the lower priority. So I have it here, show IP M route. So traffic is actually coming to router 7 through the tunnel because router 7 has recipients. Downlink here on these interfaces, there are recipients. And I've configured QoS and security. On router 12, I have QoS implemented. On the interface, I have show policy map. Interface is 0/1. So I have a policy map running here. And my policy map is showing that confirmed packets are being transmitted, exceeded packets are being dropped, violated packets are also being dropped. So if I ping and I test it from router 13, if I try to ping, I get some packets dropping and this continues to increase. The number here continues to increase, exceeded 75. After a while, exceeded 77. So I have FHRP running where router 2 show GLBP. So FHRP is being implemented on these two layer 3 switches. So that's, which also involves tracking of the uplink interfaces. The uplink interfaces have been tracked. And here I have for VLAN 10, which is active, and it is the active and is also tracking actively. Is tracking objects. And for security, I've implemented AAA on my switches so that I'm able to telnet and prove this telnet 17.0.2. One, two, three. So here's the tickets. Router 1 should be able to trace route to router 13's loopback 0. And it should navigate through these 8 ops. But the resolution restriction is that there should be no new route map or prefix list. So I'll get to my topology. So here is router 13 and here is router 1, and traffic should flow first to the hub, the customer's hub, back into the ISP network, and then hit router 13, go through and hit router 13. So here it is, I'm on router 1 now. I'm going to trace route 20.20.13.13. So the packet is dropping. So what I'll do is that since router 13 is followed and connected to router 12, I'll ping router 13's loopback from router 12. It's successful. Then I'll do the same thing from router 2 from loopback 0. You can see that it's dropping. So I'll check the BGP to show IP BGP. And on this BGP, I can see that it's not installing it, it's receiving it, but not installing it. And it's showing a next stop IP 10.0.0.5. So I'll ping 10.0.0.5. It's dropping it. Then I'll check do show IP protocol pipe begin with BGP. I want to see BGP configuration. I have a route map here, and this route map ABC is for this neighbor. So do show route map. So this route map has a prefix list and it sets the next hop to 10.0.0.5. So I will check do show IP prefix list, which is for all traffic, and do show run pipe section route map. So in my route map, I'm going to correct this next hop IP address and have it change to the right one. Then I'll remove this one. So let me clear my BGP process. See, still there. Still there. So I can see now it has changed and it has installed it in the routing table. So I can ping. So this is successful. So I'll trace it to router 8, which is the service provider, and see if the service provider is now receiving it. So I can see now that it's coming from my spoke to the service provider. Then I'll check the PE connected to the service provider's offsite. This is customer's offsite. So it's fine here, fine here, and fine here. So I'll check the hub because all traffic from spokes should hit the hub before going to another customer spoke. Show IP PGP. So I find something strange here that I'm only seeing a few IP addresses here. So I have to debug and debug IP PGP in. So turn on my logs, clear to ensure and check why it's not receiving it from the neighbor, which is the service provider. So you said there is a long AS path coming from router 6, and that means we have to check something related to the AS path. So I'm going to check the BGP configuration. Here I can see a maximum AS limit, so I will increase it. I can increase it to 20 or 15. Then so the error message has disappeared. So I'll check to show IP BGP. So now from here I can reach router 13. Then I'll come over to router 7 and see also on my router 7. Show IP BGP all. Let me see. So on my router 7, I'm only having traffic from the customer side, but traffic is not coming from within the ISP zone. So within the ISP zone, I can see these two devices, IBGP, in idle mode. So I will check back to the OSPF layer. Down, I don't have any OSPF neighbor. So now let me check and inspect the traffic through with Wireshark between router 7 and router 9 first, then I can trace upwards to capture. I'm specifically looking for OSPF traffic. So this is from router 9. From router 9, I can see that there's an area ID 00, which is a backbone area. Then from router 7, I'm going to check. I can see there is an area ID 10. So that means there should be an area ID mismatch between router 7 and router 10. And I can confirm also do show IP OSPF interface brief and find out what is happening. So I have my gig 00 here, which is area 10. So interface gig 00 IP OSPF 10 area 0. So now I have to check do show IP OSPF neighbor. Router 9 is up, do show IP BGP. All summary. Let me check now that OSPF is fine. Let me check my BGP. Oh, so I have the one to router 6 is up. Then this has moved from idle to active. So both are fine now. Then I can check if it's receiving a specific prefix. Yes, it's receiving for router 13. So I'll check it again. Show IP BGP. So this is receiving it, then I'll trace route. So this is successful. Now reaching router 13, then I'll just do a quick ping sweep. So all other IP addresses in my network from router 1, from the hub, which is router 3. And I'm just testing the other spoke addresses. Okay. So I have them all successful. Thank you.